First of all, I would like to thank the organizer for giving me the wonderful opportunity to talk in this platform. Okay, you guys already come across the algae in different parts of our globe. Okay, in a wet wall and tree bark, soil, and water bodies like lake, funnels, and ocean. Algae are the most common and widespread primitive group of autotrophic organisms that are ubiquitous and cosmopolitan. You can find the algae from everywhere in this globe. So it will grow in various conditions. It will grow
Algae.
from glacier to extreme salinity or extreme thermophiles. In any condition, you can find the algae in nature. It has wide range of adaptability, and they are primarily aquatic. Basically, we see algae from aquatic, but you can find from terrestrial and subaerial forms as well. It's been in this planet about 500 million years, and it's supplying the oxygen to all the living beings from its origin. Algae has been used globally for various purposes about centuries. It's not new to us because we are using it very long time already. Algae measures its range from unicellular, that means a few micrometer microscopic form, to gigantic 70-meter broad algae forest. Algae are the most attractive and beautiful form of nature. I could say this one as a microscopic ornament in this nature. So you can find different size and morphology of algae. So you can see from various size and various type of algae. When you see the cultiferous morphology and silicate morphology, you can see different silicate deposition under the microscope. According to that, we identify and classify the diatoms according to the silicate deposition. That silicate deposition itself wonderful, and you may not imagine how it's created and how wonderful it is without seeing it. When you sit and see under the microscope, you'll forget the time and you'll forget yourself. That means it's very wonderful and it will attract your mind totally. It's mind blowing. Not only the microalgae, the macroalgae also very nice and attractive with different shape and morphology and color. When you go to ocean or any water bodies, these forms, it's not making any flowers at all, but by appearance itself, it will attract and mind blowing. You'll forget your time and you forget yourself totally. So it's very attractive. It will attract within a second. So it's very good. There are 16 different classes of algae, range around 73,000 of universally accepted algae. There is 2,000, 200,000 algae identified globally, but accepted 73,000 species are universally accepted by scientists right now. Though there is 73,000 algae, we are not able to cultivate and uh, understand the potential of all of it. We hardly know about hundreds, few hundreds only. So what we have plenty of opportunity to detect what is there in the other algae. Though the potentials are unknown for many of the algae, so we can see how to find the potential by culturing it. There are a lot of opportunity out there. Basically, all other microorganisms like bacteria, fungus, it's easy to grow. Most of the potential we already established, but the algae, we really need very patient to analyze this one. So we have plenty of source to find what is there out there. Now I'm going to talk about the algae product. What are the algae product available in the our market? And you can see spirulina from decades already. It's promoted as protein supplement, because whatever available in the nature does not comparable to its digestible protein. It has up to 65% of protein, and it has very good antioxidant like phycocyanin as well. So when you extract the phycocyanin, it will be having very good nutraceutical and pharmaceutical value. We'll see later about this one, how the production will be. Okay. When you talk about astaxanthin produced by naturally with this Haematococcus fluvialis. Haematococcus cells are like look this one, when it's formed like a spherical spores, it can withstand up to 60 years for any condition of the nature. So because it possesses the antioxidant, very good antioxidant astaxanthin. This antioxidant is 6,000 times better than any other source of antioxidant. Other well-known product is beta carotene. Basically, beta carotene come from papaya or carrot. Those are very tiny compared to this extremophile Dunaliella product of beta carotene. This beta carotene very rich and 400 times better than any other source of beta carotene in the nature. Not only the carotenes, we can get fatty acid, polyunsaturated fatty acids out of the algae. We can convert this into, we'll distillate into omega oil. When you, this omega oil has wonderful role in our daily life. It will establish your human brain growth and many other physiological activity will be smoothened by this omega oil. It's very good for health. Now we are all using the food grains as a source for food ingredients. In future, we are going to have algae flours or algae product as a food ingredients because of its sustainability. We can grow it everywhere and we can get plenty of product in short time. So we can going to have the superfoods and food ingredients out of algae in future. Not only that, there are plenty of mind-blowing seaweeds snacks out there in the market. When you eat it, you'll forget yourself as well. Those are very tasty and delicious. Algae seaweed salads or other food ingredients are available in the market. You can see wonderful algae seaweed salad. It will be mind-blowing and when you eat, you'll forget yourself as I mentioned. It's wonderful and it comes from nature. And there are plenty of products left with alginate and agar-agar and carrageenan isolated from algae or used in the food ingredients. Carrageenan is available in almost every products that you use in your daily life. You can find in your toothpaste. You can find in ice cream, your face cream, and food products, different food products. So it's available everywhere, and you may not understand what it is when you use it. Those are very important, essential product from it comes from algae. Food coloring agents. Food coloring agent comes from algae. When you talk about phycocyanin alone, its primary blue color, you can convert this primary blue color into different colors with adding other colors. You can make it come yellow, green, light blue, and pink, and violet, and brown colors out of this phycocyanin itself. Also, there is other product, phycoerythrin, allophycosanin, will give you other colors as well. You can make these colors. You can make these colors. We can make this color for food ingredient coloring, food coloring agent, also as a ink or other purposes. So algae can produce wonderful color for our usage. Aqua feed and cattle feed. Aquaculture are very different around the microalgae. For the rotifer and coffee pods will surely require the microalgae because it cannot feed that micron size other foods. So these are it will play very important role in aquaculture industry. So algae paste, the microalgae like Nonochlorosis, chlorella, and Tetrazois, those are the according to the size, the microalgae will give feed the copyboards. The copyboards will feed the fish as a feed. So we can give it as a aqua feed directly, as well as make it into fish feed by making pellets of different size of fish, and you can make cattle feed out of algae. So you can convert this algae waste, algae waste from other products as a very good source of cattle feed. Since it has a very good amount of protein and carbohydrate, we can kind of mix with other nutrients, and we can make wonderful nutrient rich food feed out of the algae. Not only that, algae crude oil we can make from algae. We can distillate it into petrol, diesel, and other fossil fuel alternatives. Bioplastic and paper can also make out of algae. Not only that, okay, endonucleases enzymes we can isolate from cyanobacteria. This comes under the algae. So, eukaryotic, prokaryotic algae. So these enzymes are used in the molecular studies broadly. Whatever available in the markets are expensive. When you make out of cyanobacteria, it will be affordable to the researchers. So we can make um, this microchemical out of algae. Not only that, the fluorescent label colors. Lot of experiment requires a fluorescent labeling because these colors will fluorescent under the UV light. Under the UV light, olefacin and picoerythrin can give you the color yellow and pink while exposed to the UV lamp. So it will give you wonderful detection power when you add into the your source of experiment sources, and you can detect the um, your experiment products under the UV lamp. Not only that, product energy alternatives like bioethanol and biogas you can make out of algae. Though it's sustainable and we can make it as a renewable resources, we can affordable to make algae in everywhere. We can convert this way as a bioethanol or biogas by the process. Not only that, you can generate electricity out of it. We can generate electricity out of it. Since the algae can do the photosynthesis with the use of light, you can find this one. Okay, you can use it as a microbial fuel cell. Fuel cell directly by growing it. So when you treat the waste itself, you can generate electricity out of algae. When it's grow, then we can get electricity by microfuel cells. We can with the anode and cathode. Not only those things, cosmetic and algae colors. The algae colors and algae ingredients play the major role in cosmetics. Though it's natural and good for health, people are looking the algae product globally to use it, and we have plenty of sources for ingredients from algae. We have a face mask and cosmetic ingredients and different colors and sunscreen made out of algae. Not only these, many other cosmetic products as the products like asalindin, betaquin, everything goes into here. Medicine and medical devices. The alginate play a major role in those things. Like when you see this alginate for the stomach issue, you can get alginates as a floating agents, and this will give good relief in your stomach issue. And it has very good wound healing properties. So most of the band-aid which you use it for the wounds has this product. Not only that, as a medical device, the alginate you can convert this alginate and make it a clay type of measure, and you can measure and understand your shape of your teeth by the dentist, and they will duplicate your teeth morphology according to this impression. They'll make the impression, and it will long last, so they can make the exact um, shape of your teeth out of this impression. So they will mold it and make your uh, tooth whenever you break a dentist records this very importantly. Other things, antibiotics and antiviral products from algae. There are plenty of products out there available in the market. Also, there are a lot of research going on as well. Algae is a very good anti-viral anti-HIV product. So, like cyanovirin play a very good role in anti-HIV, and other antimicrobial products like cryptophycin and chlorelin, like antibiotics also available in the market. Not only those, we can treat the effluents with algae, like bioremediation. One of our colleagues, one of our brilliant scientists, Professor Siva sir, is working for tannery effluents treatment. The tannery effluents has a lot of chemicals and um, uh, plenty of tannins. It's very hard to remove by other treatment process, but our algae can treat very nicely, and you can make byproduct out of it. So not only that, in Malaysia we have plenty of problem with palm oil product production. It will produce palm oil as well as plenty of stinky palm oil effluents. It's called foam. The foam is very dark and thick like a charcoal. We cannot charcoal tar. We cannot treat easily by other resources. They left this one for a couple of years to decades by its own. But we can treat that one by algae with of bioremediation. It will treat wonderfully the palm oil. Not only that, we can get biofertilizer out of algae. The cyanobacteria is the one fixing the nitrogen. We cannot get fix that affordable range of price by any other sources. So it's very wonderful biofertilizer by nature. Also, growth stimulant we can get from algae. It's wonderful growth stimulant. Okay, I use this one for my PhD studies as well. It was very good root and shoot growth under the tissue culture. Also, the field trial. Okay, so this product, this growth stimulant, you no need to waste your algae. You can use this algae for other product, and the waste of this product, you can convert it to growth stimulant. So there is no harm. It's a byproduct. So we can use it as a byproduct. As I mentioned last time, when you grow algae for other product, it's wonderful. You left off with zero waste. You can use when you extract oil, you can convert it into renewable fuel and omega algae meal. All of it, out of it, you can make all the products from one single algae. When you do the algae process, when you do the algae process, you can get out of it. You can brilliantly get and you can incorporate all the process to use the different byproduct, not only depending on the one product. So you'll have the multiple revenues for your products. What about the market for the algae? Current algae market has can show you the um, result. Health food, you can go up to 2,500 million USD. Functional food and DHA, those are having plenty of market out there. It's enormous. We have source. We have plenty of opportunity to play with the algae. I'm not telling us magic. If you go and Google it, you can find Alibaba or Amazon the prices. When you have 5% astaxanthin, you can sell up to 600 USD per kilogram of biomass. How good, how good property is this one? It's good, very good profit business. When you have 2% extra, you can send up to 250 USD of for 1 kilogram of biomass. And if you extract this to algae assassin only resin, you can go up to 2,500 USD per kilogram of assassin. Picosanine, you can go up to 350 USD per kilogram of picosanine powder. You can go up to 250 USD for beta carotene. There are plenty of market available out there. Okay, now we will come to the important role. Yeah, those are the previously we saw uses and the market. Now we can see how we can make the algae by commercial production. Those are the microalgae and macroalgae. I'm going to summarize in this coming slides. Okay, basically, if you want to do algae business, you have to have the better potential algae for your business. So you have to isolate the those algae from the environment, and you have to enrich and isolate as a unique algae, and you have to scale it up for your further use. How? Okay, once you are having the pure algae, you cannot go directly to your cultivation size. You have to scale it up according to your usage. So you have to go step by step to use it as a seed culture. It varies from your requirements like this. So from the petri dish, you go to your flask, potted flask, then it goes to bigger flasks, then it's go to columns or other cultivation systems. Okay, this is one of my industrial production of astaxanthin. Okay, astaxanthin production has very bit of difficult than other algae cultivation. When you grow spirulina other algae, you can cultivate nicely, but astaxanthin is bit uh, complicated. Not that complicated. If you have good knowledge of this, you can get it out of it. Okay, astaxanthin. When you produce astaxanthin, there is two stage of this algae. One is green stage and red stage. Those are very important. Okay, you have to grow um, unicellular algae. This is a unicellular algae, flagellate algae. It can move like a suppose. Then it will turn into the spore. So the move this zoospore and the turn into the apneic spores. When it's turned to the apneic spore, you have to transfer to the red stage. very carefully to make carotene inducing stress. So there is two stage of this one. One is the green stage. From the laboratory, the pure culture, you scale it from the different scalable, your requirement commercial vessels, and you turn to red, and you have to harvest it. You have to sediment this algae for further production. Then you have to harvest the whole hematococcal cells are very hard to crack. Those it's like a spherical, very hard structure. You need to use special equipment to crack it, like the homogenizer. It has a zirconium seed like a diamond. It will crack the cells so that you can extract acetylene out of it. Once extracted, we have to go freeze dry or spray dry to dry the uh, liquid, acetylene liquid. Once you make the powder, you can use it as a powder, or you can extract by critical CO2. Then you can use for as a sorry, you can use as a acetylene oleoresin. Yep, this process looks very simple, right? But as a scientist, you have to do most of the thing by yourself, by because those the technicians are there, you have to explain them and you have to make them to use of it. Sometimes you have to work in every field to create the system. So we had when I work, when I grow the algae in the laboratory, I need another vessel to scale it up. So I was trying different type of system for my uses. I used the aquarium and big aquarium like 2000 liter. When I use the aquarium, it has different problem to has. It's given different problem to has, and we cannot create more. So we have to go next stage. How affordable and how we are going to use our indoor, because pneumococcus record the optimum temperature. So when you put in the indoor, the system going to be very compact. If it is compact only, you will be it will be economical. Otherwise, you have to give aircon to everything. It's not that easy. So we were trying to create polyvac system in different sizes, different types. We are using the small 1 week small half-meter size bags and 6 meter tall bags, and all the system has the problem out of it. When we use it, it has different problem. It shows the bulging, and there is a auto accumulation. Other things makes everything problematic, and think and make out of it to make the excellent cultivation vessel out of it. So we were trying different things. We were trying the vertical column and horizontal tubes. Every time as the problem. So we had 6 meter tall and okay. Then we tried the 2 meter wide bags directly with this, and a bulging problem occurs, and we give the bandage like this system. It's not working, and and accidentally I cut those bag. I cut those and hang the same system like three thing. Wow! Then I got my system already, and it's very difficult also to find this one. So different stage has different uh, problem for you to understand and rectify it. So apart from these bags, and make this to hanging into the racks, the commercially available racks, so that I got my column like this. Then only you got these columns very close. We can put very closely in, and we can stack as many as possible in the containers. So this system is wonderful. It's working very nice for the emetococcus. So when you do industrial approach, there will be um, some issues will come and change. It will check your next level. So we have to go with this. This is what assessment in next. Okay. Algae production products product for omega oil from nanocloropsis. This nanocloropsis can grow nicely in the PBR, photobioremediation, and open area. We no need to control the temperature. It can grow up to 35 degrees Celsius. So we put in the 120 meter long, 120-meter long PBR, vertical PBR, and it was 120-meter long and 6 meter tall, and 85,000 liter capacity. Each PBR is 85,000 liters capacity, and it's huge. And as I mentioned, this also has a lot of issues. We have to rectify accordingly. Once you grow this algae, you have to turn this one to fermentation stage to enhance your fatty acid. We do have that one. Then harvest and spray dry it to make the powder. That's powder you can convert into the fatty acid and distill it into the omega oil and make the soft gel for commercial purposes. Next, phycocyanin make out of spirulina. Phycocyanin production. Yeah, it sounds good, right? Spirulina is a wonderful algae. It can grow in extreme condition, like it can grow up to very alkaline condition, up to 11 plus pH. So when you grow spirulina, it's easy. Other algae or other microbes, other zooplanktons will not grow easily in this pH condition. So it's easy for us to cultivate. One moment. Easy to cultivate. So we can use these open ponds to cultivate the algae. தம்பி ரெக்கார்ட் பண்ணிட்டு இருக்க ஒரு நிமிஷங்க அதுக்கு பாதியில் நிறுத்த முடியாது நான் உங்களுக்கு கூப்பிடுறேன் பை so we can cultivate this to open pond itself, then harvest and process for phycocyanin. So you can these also making pond also you need the expertise. As a scientist you may not know the construction side, you have to understand the difficulties and technical issues. With your technical people you have to rectify it and you make your systems work for your products. So this is our phycocyanin production plant, but since it's in Malaysia where we have plenty of rain issue, every afternoon you'll get the rain, not only small drizzling, it's not that kind. In Malaysia we have very good tropical region and heavy rain. It will fall like half an hour to 1 hour heavily so that your pond can overflow. If you are not having the greenhouse, you must have to have the greenhouse to avoid this rainy season. So Malaysia we have the greenhouse system for my open ponds. Okay, once you make the spirulina, you have to track the cells to extract the phycocyanin. Then you have to purify the phycocyanin with your technical techniques. Then you have to dry from spray dry or freeze dry to get the powder out of it. Dunaliella salina process for beta-carotene. We'll cultivate the Dunaliella, then convert it into carotenoid stage, then we'll harvest it and dry it and make the extraction out of it for the Dunaliella. Same, whenever you play with this, you'll have a lot of not the issue. It will improve your talent. So there will be some challenges. That challenges you have to face it and improve. So when you do the colonization, if there is a contamination or there is a salt level and other factors can affect phycocyanin the carotinization process. So you have to know how to convert the carotenoization, then only you can get your better product. Otherwise, you won't get the better product. This product it won't turn to later. So we'll convert this to beta carotene by doing properly. Okay, you already got your product. Okay, you product like astatine, picosanine, and beta carotene, omega. Your industry must have the in-house facility to check the quality control. Quality control, if you have the packaging unit as well, very good for you. So you can pack yourself and you will have the better profit. Okay, so we do have our in-house quality control analysis for all other the products. So we'll check all the products in-house. Some of the products we send it to outsource for double confirm our product quality. So we have to analyze the product quality when you do the quality industrial product, because some of the time your product will not meet the customers requirement. Maybe you'll end up with the contaminations or heavy metals, or less quality of the product. Those are the things are not good for your industrial products. You have to make sure that product quality constant and consistent to maintain your customers. So you have to have the quality control analysis. Okay. The, until now, we seen the microalgae cultivation, as well as now we are going to see seaweed cultivation. To cultivate seaweed, we have to have the ocean environment to cultivate it. So we can have the net system to grow the algae. If you are not having this one, it can escape from your anywhere due to the tide. So you have to make the mesh to um, keep your algae, and you can cultivate it and collect for your further process. Not only that, you can grow the macroalgae as well as in the deep sea cultivation mechanism to your further utilization. There are the technique you can learn very easily, but unfortunately, these algae field, not many institution or companies will not teach you how to grow it. Sometime you have to go and find yourself to find the your learning process. So there are a lot of YouTube channels or other things are there. Unfortunately, not many institutions will give you short time to teach us. But spirulina and other things, we do have some coaches. You can contact us, so I can direct to other product algae related product industries. Conclusions. Okay, algae everywhere. As I mentioned, it's ubiquitous in the nature, and it has ubiquitous uses in our human kind or other things. In future, algae are going to be our future food. Algae are going to be the superfood for us with greatly packed nutritive value. Algae are going to be the uh, one which fulfills our future world requirements of foods, because soon we are going to eradicate, or we are going to convert our aquaculture, the agri field into algae most of the times, because of its easy cultivation and other things. So future foods going to depend on our algae. Algae are going to be the future trustworthy cosmetic stuff. Algae are going to be the growth promoting and nutritional fertilizer. In total, algae are going to be in part of our everything in our near future. Let's grow with algae. Thanks. Let's join hands to develop sustainable ingredients from algae. I thank all my companies who teach me to grow me like this position. So I thank everyone for following me. Thank you. Thanks, one and all.
Friends, good afternoon. So thank you for joining all of you, and I'm so happy that the speaker gave his time and given the things. So we'll post the feedback link in the comment section. You can have kindly have a look into that, and you can fill the things. Give us just 2 minutes. I will just to post the feedback link. Okay, so I hope everyone enjoyed the session, and it's time for conclusion. I'm happy to deliver vote of thanks for the 22nd session of Aari Bioscience webinar series. I would like to thank Dr. Mayakkannan for readily accepting our invitation and delivering an insightful presentation. The in-depth knowledge of him in the field of algae and
Good morning, everyone. This is Dr.
industrial
Michael
applications
going to talk
has
about
been
algae, commercial production of potential
interesting to
algae
all the
and
audience,
ubiquitous uses.
and it helped us
First of
enormously
all,
in
I would like to
understanding the importance of algae
thank
and their various
the
applications.
organizer for
He
giving me
shared
the
detailed
wonderful
information
opportunity to
regarding
talk in this platform.
the algae and their
Okay,
utilization. Hence, on behalf of e-teaching Tamil and
you guys
Annakkili Research
already
Institute,
come
I heartily
across the
express my sincere thanks
algae
once again to Dr. G.
in
Mayakkannan.
different parts of
We
the
always look forward to your able
in
guidance
a
and support, sir.
wet ball
I also wish
and
to thank our
a
audience
tree
for
ball,
their great interest in the session and also
soil
for participating.
and water bodies like
Even after the
lake,
technical
funnels,
difficulties, they
and those.
rejoined the session. Thank you all.
Algae are the most common and
Without
widespread
your
activity
support, we
of
could not have
arthropathic
succeeded this. Last
organisms
but
that
not
are
least, I thank Board of
ubiquitous and
Directors,
toxic.
scientists, and other
You can
staff
find the
members
algae
of
from everywhere
AARI for
in this
continuously
world.
supporting me in organizing
So it will
consecutive
grow
webinar
in
sessions.
various conditions. It will grow from
Um,
glacier to extreme
I
salinity or
thank you
extreme
all. I am posting the
thermophiles.
feedback link. You can fill
In
and
any
get the
condition, you can find the algae in nature. It
links.
has
Okay,
wide
links. Just check the
range
link
of
whether it is working or not.
adaptability, and they are primarily aquatic. Basically, we see algae from aquatic, but you can find from terrestrial and subaerial forms as well. It's been in this planet about 500 million years, and it's supplying the oxygen to all the living beings from its origin. Algae has been used globally for various purposes about centuries. It's not new to us because we are using it very long time already. Algae measures its range from unicellular, that means a few micrometer microscopic form, to gigantic 70-meter broad algae forest. Algae are the most attractive and beautiful form of nature. I could say this one as a microscopic ornament in this nature. So you can find different size and morphology of algae. So you can see from various size and various type of algae. When you see the cultiferous morphology and silicate morphology, you can see different
So there is a one question
silicate
by
deposition under
our
the
audience.
microscope.
The
According to
question
that,
says,
we
sir, can
identify
algae can be used
and
to
classify
treat
the
wastewater? Yes,
diatoms
it can be
according to
used
the
to treat
silicate
wastewater,
deposition.
and it
That
has been
silicate
done in
deposition
various parts
itself
of the world and India.
wonderful,
In India, Dr. Sivasubramanian
and
has
you
doing it
you may not
in great
imagine
manner, and he
how
has
it's
collaboration
created
with
and
various
how wonderful
nations
it
and
is without
industries. He is
silicate.
doing
When
it by
you sit and
remediation.
see under the
If you
microscope,
search in
you'll
internet called
forget the
remediation,
time,
it will come
and you'll forget
PHYCO.
yourself. That means it's very
Remediation.
wonderful and it will
Okay,
attract
so
your
there are so many
mind
works are
totally.
going
It's
around
mind blowing.
on algal
Not only
remediation
the
using algae treating the
microalgae, the
domestic and industrial
macroalgae also very
wastewaters.
nice and like
Okay, so that's
attractive,
the integrated
different
approach people
shape
are
and
doing.
morphology and
And
when you
regarding
go
the
to
if
ocean
so,
or any
what species
water
can be
bodies,
used? For that, the
these
answer is
forms,
if you
it's
choose
not
most
making
of the
any flowers
chlorococcales
at
members,
all,
they
but
have tend to grow
by
in various
appearance itself, it
like
will attract and
climatic
mind blow.
condition and nutrients
Forget the
fluctuations. They have
work
the
time
capacity to
and you forget yourself
withstand those
totally.
things.
So
So
it's
most
very
of the
attractive.
chlorococcal
It will
members can be
attract
used to for
within a second.
wastewater
So
treatment.
it's
And the
very
best
good.
thing is like if you
There are
collect algae
16
from
different classes of algae,
mm, any
range
wastewater place, those
70
algae also
around
has the capacity to
73,000
grow
are
on the
accepted,
wastewater
universally
place,
accepted
and they
algae.
can fight
There
used to
is
treat the wastewaters. Okay.
2,000,
So is there any other
200,000,
questions? Dr.
200,000
Mayakkannan also is there with
algae
us.
identified
So if you ask any
globally,
questions, he will
but
also
accepted
answer in the
73,000
chat
species
section.
are
So if you have
mostly
any queries,
accepted
kindly
by
post it on
scientists
chat
right now.
section.
Though there is 73,000 algae, we are not able to cultivate and uh, mm, understand the potential of all of it. We hardly know about hundreds, few hundreds only. So what we have plenty of opportunity to detect what is there in the other algae.
Regarding culturing dead meat, so regarding the Desmits cultures, someone has mentioned that there is a contaminations. Yes, when we culture algae, most of the time we used to get contaminations. So you have to do continuous streak plate methods and other things. It will help you to further isolate the organism without any contamination. And Dr. Jackson Achunkunju from ASU, from Oman, he has messaged. So thank you, sir, being with us. While scaling, I found complex interference with chlorocacum. I would love to show my culture in big scale. Yeah, if you have desmids with you, you can isolate you have to check like that culture is completely axenic. Okay, you have to do several subculturing. When you do several subculture, you will get the pure culture. So when it is pure, you can upscale it easily. Okay, and if you have like chlorocacum, if you want to culture like that time, you can use this nitrate and other things like NPK sources. If you use little high, it will help in to grow faster and it will give higher biomass. Okay, so you can easily scale up. If you have any other queries, kindly post it on chat box. Like I found contamination while scaling only. So actually if your culture is pure, then there won't be a much problem in scaling up. There is no difference. Like same like how you are culturing, the same way you are going to do scaling up, right? So if whether your culture should be having some contamination or the medium which you are used to for scaling up. So while scaling up, the mediums also need to be like, if you want to in pure culture, that time you have to be careful with the mediums purity. Okay, that should not be having any contamination. So might be some error might have happened. Without that, like contamination will not come. Okay, whether it should, the source should be like, it should be from the algae which you used mother culture, or from the medium or the glasswares or something. So some source should be there to give the contaminations. So you have to be careful with everything, like it's, everything should be axenic in while doing culture and scaling up everything. Okay, so good luck for your work. Hope you will get more stud cultures in future. Is there any questions? You can post it. I really sorry what happened in the morning. So this session supposed to be happening in the morning, but unfortunately due to power failure we could not complete the session. And luckily, with the support of Dr. Mayakkannan, we could have it in the afternoon. So thank you, thanks. I would like to thank him once again for the support and effort he took for the completing this session. Thank you. And I also thank all the audience who joined. We are happy that many audience has joined back in the afternoon session. So if anybody have any queries, you can post it. So regarding that Desmid questions, and Dr. Mayakkannan has answered, many of the Desmid and Signimetals forms are naturally having endomicrobial consortium in it. In it, this it bit challenge to culture, but repeated culture and antibiotic composition amendment can heal. Okay, so the same like where once you have the problem of contaminations, you have to do adequate subculture. Okay, whenever the growth is shown up, from that you have to repeatedly you have to culture. So, and there are so many antibiotics also we can use it, but using like higher amount of antibiotics may affect your culture also. So you have to design for your own culture how much antibiotic, how concentration has to be used. Okay, so thank you Dr. Mayakkannan for giving a wonderful answer. So I have audience don't have any other questions, Dr. Mayakkannan also available. So if you have any questions, you can post it so that we could answer it. So after waiting this much time, I don't find any other questions. So I consider that there is no questions from the audience. So I would like to conclude this session. Thank you all. I will just end the stream. Thank you for joining. I hope everyone got the feedback link, and also I will post it in the comment of this video. So this video will be available for future reference. Many of you have asked for